questions.
All right, guys. You guys, anybody have any more questions from homework stuff? Don't forget the quiz is today. Don't even ask me to push it back anymore. It's today. So it'll be due tomorrow. Any questions? You guys are all right? Okay, all right. Let me see. So I added some good questions in office hours. That's always good. If you guys are all good, holy crap, that's exactly where I need to be. That's crazy. We'll get back into this quadratic business. All right, so there, I'm going slow because I want to make sure. Let me know now if you got any questions. Okay, so a quadratic is of this form here. This is the very last thing we did yesterday. The only one of these A, B, and C that cannot be 0 is A.
You're not sharing screen.
Oh, shit. Thanks, Phil. I'm like, I can see it fine. Oh, crap. There we go. Here we go. Let's start over. This isn't being recorded. Oh, yeah, it is. Shit. All right. We can cut that and edit, right? No? Oh, well, I'm alone. There's nobody else over there. Between these A, B, and C, why does it make sense that A is the only one that cannot be 0? What would happen if A was 0? What kind of function would it be if A was 0?
Be a linear.
It would be linear, exactly. If you kill this term, you have a linear function. It's not quadratic anymore. I don't know, guys. I'm sorry. Did I my Wi-Fi is fine. I think it's Zoom just screwing with me. It says, oh, you haven't been Zoom bombed yet. Let's just screw with you. I don't know if I just disappeared or just stopped moving or whatever. I was disconnected there for a minute. You guys are all like, oh man, maybe he won't come back. No class. Oh, there he is. Damn. All right. All right, let me share this again. Let's see if I can stay connected. All right. So the last thing we were talking about was A can't be 0 because otherwise it would be a linear function. That's right. And we talked about which ones of these are not quadratic, and it turned out to be C because it had a higher power. The power of 3 is too big. And then this guy's got a square root, which is freaky. Quadratics can't handle the square roots. Okay. How you guys doing out there? Tell me this. Can somebody tell me? So let me cross out the ones that are not quadratic. So this one's not quadratic, blah, 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 and this one's not quadratic, blah, 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 blah. Which one of these would be a parabola that opens down? A sad parabola.
D.
A, B. Say again, sorry.
D.
D is in dog? No.
B
So
is
multiply this.
something.
Yeah, B would be the one that opens down. Why? Because what's in front of the x squared?
Negative.
Negative. Kick ass. So if the x squared term is negative, it opens down. If the x squared term is positive, it opens up. So very often when you're talking about throwing a ball or you're talking about profit or something, you're going to have a downward parabola, because if I throw a ball, it's going to look like that. It's going to be a downward parabola. It would be exceptionally weird if it looked like an upward parabola and just left the earth. And you're like, ah, it's my only baseball. All right. And now it's orbiting the earth. Damn it. All right. All right. All right. So let's leave this behind. Let's see, what was it? There was something else I wanted to show you. Oh yeah, this is what I want to show you. All right, let me do this. Look at this. Can you guys take a minute and write that function down? Look at that beautiful function. It's so beautiful. Okay, now let me show you something remarkably cool. Let me stop sharing for a minute. Let me pull up this website. There's a kick-ass website that I'm almost certain some of you guys know about already. It's called Desmos. So let me see. Let me pull this up for you guys.
If I missed that function, you told us to write down.
Oh, don't worry about it. I'll put it up here too. All right. So it's called Desmos. And it's actually a nice free online graphing utility. Has anyone ever heard of that before? No? Okay.
I haven't seen
But if
this
you go to
particular one, though.
Yeah, if you go to desmos.com and click on graphing calculator, then watch this. I'm going to put that function in. I could even put it in there exactly like it is. F of x equals -6x. Oh, yeah. And then you have to use the little caret. It's above the 6 button on your keyboard, little to the second power. And then you hit the over arrow to come. See how I'm up there? I got to hit the over arrow to come down. Plus 2700x minus 63,500 and I'm sorry, 750. So that's the function. And let's see now. I see how I can't see shit. So let me just kind of use my mouse to zoom out. Oh, there's the function. Look at that. Keep on zooming out. There, look at that. That function is insane. It's a little too insane for this. Did I miss something? No, that's the actual function. That's insane. Yeah, it just kind of goes forever. Can somebody tell me, you guys can actually do this. This is not very the best function to start with here because it's a little extreme. Can you guys tell me what the y-intercept of this function is? What's the y-intercept of this function?
-63,000.
Yeah. -63,750. That's right. So it's going to hit the y-axis way down at -63,750. So if I zoom out far enough, this is kind of insane. Oops, let me zoom back in. So look here. Here's -60,000. So right around there it is. 63,000. Yeah, this is a little extreme of a function. Let me just say that. I'm going to put a better function here in a minute. 63,750. It hits the it's the y-axis eventually. Anyway, this is such a crazy function because it's got these huge ass numbers. It goes up and down really fast. So let's do this. Let me kind of reset here. All right. So let's put a more normal function in here. Let's say y equals x squared. You can do it, Jeff. Let's say -3x minus, let's see, what do I want to do? Yeah, -10. Kick ass. That looks a little more manageable, right? There you go. There's your beautiful parabola. And if I just hover over, if I just click on the function, I can actually see the x-intercepts. Do you see how it finds them for me? The y-intercept. And of course, what's this point down here?
Vertex.
Vertex, kick ass. So this is a free utility. You graph any function, and if you click the function, it actually finds the intercepts. It finds and it finds the important points like the vertex. That's crazy. That's crazy, Zosh. Now let me show you one more thing. So very often, actual profit functions look something more like, let's see if I can make this more extreme. There we go. Oops, it's a little too extreme. There. And it actually would even be worse than this, but you have this extreme low, and then there's a maximum right there. That's not the vertex because it's not a parabola, is it? It's this freaky Loch Ness Monster kind of humpy dude, right? But that is the maximum there. And there's a minimum down there. Poor little thing. Anyway. So that's kind of a really cool free online graphing utility that you can use. There is one question they ask in the homework where they say use a graphing calculator or a graphing application. You could use this. You guys, everybody with me out there? Okay. So let me stop sharing because I can't see any of you. There you go. All right. So coming back to the book. And let me show you an example of what I'm talking about with this. Let me see, do they have a normal function I can work with? No. Okay, all right, I'm not gonna worry about it. Oh, well, let's see, something like, yeah. So here. So like if I wanted to find the vertex of this guy, 8x minus x squared. What you could do, so 8x minus x squared, if I put this bad boy in Desmos, bam, there he is. And he's opening down just like we predicted, right? Because there's a negative in front of the x squared. There's the vertex. It's at 416. I love it. So if I said, what's the maximum value of this? You would say, oh, it's 16. That's the highest output that it gets. Obviously, if it opens up, it would have a minimum, right? It would have a valley. It would have a minimum. If it opens down, it has a maximum. Okay.
How would you can you find that without using the graph?
Ah, you're awesome. So watch this. I'll show you a little something. I'm going to stop sharing. Let me show you something that goes beyond what the book decides to share with us. Let me share this. So let me show you a little trick. If I have a quadratic function in this form, I can always find the x part of the vertex by doing negative b over 2a. And this is all kind of like, I guess, off the record or on the side or whatever. And you can actually prove this using something called completing the square. But let's see. Remember we got 416 for the vertex just now on Desmos for this guy? So let me write this guy. Let me write him in descending order. So negative x squared plus 8x. Can somebody please tell me what a is for this function here? What's the value of a? Negative 1. I love it because it's the number that's in front of x squared. So it's negative 1. What's b?
8.
8. So then let's use this little shortcut, dude, to find the x part of the vertex. It would be negative b, which is 8, over twice a, which is negative 1. Negative 8 divided by negative 2 is 4. Holy shit. That matches up with what we found, right? How do I find, is everybody, let me stop for a minute. Again, this is kind of like a little extra note. This is a beautiful shortcut to find the x piece of the vertex. So now I know the x piece is 4. How do I find the y piece of the vertex? What do I do if I know what the x value is, but I want to know what the y value is? What do I always do?
Plug the x value into the equation.
So now I can do f of 4. Let me plug 4 in for x. Negative 4 squared plus 8 times 4. Negative 16 plus 32 is 16, and that matches up exactly with the vertex we got on Desmos. Is that cool? It's like I planted you. Vu, was that you that asked me where that was?
Yeah, I was just wondering how it worked.
Oh, it's beautiful. I love it. It's perfect. That's exactly what I want to hear. I want to hear somebody go, that's nice. You could find out on the website, but how do you do it? We're the humans here, Jeff. We should know how to do this shit. I'm like, yeah, there it is. Okay. If you're curious about where this comes from, you'll have to email me. I can send you some handouts related to that, but we're not going to talk about it in the class. Okay. Do any of your homework talk about this? No, don't freak out. All right, let me clear this away. Clear. Let's see. Blah, 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 blah. Was there something else I want? No. So the homework here is going to be pretty straightforward. They give you a graph, like we did a problem like this, about how high was the ball when it was kicked, so you can estimate it. So this is all just estimation, right? They don't really give you a good enough scale, so you just estimate. Where it gets more interesting is when they give you a formula right here, and you have to use the answer you got for number 6. You have to plug it in. So that's not a big deal. So they're going to give you, you're going to figure out how many seconds, and then you're going to plug it into this equation, and you're going to see if you were about right, how right you were. Blah, 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 blah. There was one question. Was it here or was it somewhere else? Oh, well, it must have been somewhere else. Okay. Maybe I'm remembering wrong. I thought for sure it was in here, but maybe not. Okay. So that's section 4.7, all about quadratic functions. All you need to know how to do is to read a graph and use the function they give you to plug stuff in for it, right? I don't think there's anything too freaky in here. I thought there was. No, there isn't anything too freaky in here. I like it. Okay. Yeah, good. So now the next thing we're going to get into is kind of a little bit interesting. We've done some of this before. So I think I told you last time we were going to get into a little more purely algebraic stuff, right? So let me do this. I'm going to get off my ass. I'm going to see if I can do that. And I'm going to use the board. All right. And we're going to talk about more purely algebraic stuff. And hold on. All right. Is that good? You're a little close. Step back. Okay. Ship it. Okay. Now, I'm pretty sure this has come up before, but I could be wrong. Well, this definitely has. Can somebody remind me how to do something like this? What would you do here?
Distribute.
Yeah, exactly. So you distribute. Now somebody else help me out. What do you get when you do 2x times x squared y? You get 2.
X power to 3.
Yes, x to the 3rd. And then, of course, a y minus 10x.
Squared.
Okay. All right. So that's nice. I mean, distributive property we've done before. It makes sense, I'm hoping. And I'm pretty sure we've done this also, but maybe not formally. So what the shit would you do with this. Oh, yeah, somebody's got it for me out there. I'm pretty sure I've asked you this before, but I can't remember. If everybody knew, does everybody see what Riley wrote down in the chat? Does that sound familiar to anybody? Has anybody ever heard that term? I did go over it. Okay, thank you. I just can't remember. Did I tell you how much I hate it?
No, you have not.
It's all right. So you ready? Here we go. I hate it. It's dumb. It's one of the dumbest things. Let me tell you why. Not the actual process. The process is easy enough. And I don't know if I can get this across to you. What does FOIL stand for? First, outer, inner, last. It's kind of like a mnemonic device. I don't need it. You don't need it. And in fact, it doesn't help with what if one of these gets bigger? There's no, so here's first, outer, inner, last, where you do that times that. So it just tells you out, but look, watch. Do you see how here I just had one thing to distribute and here I have two things? I don't need no freaking FOIL. I'm not baking potatoes. I just need to do X distributes. Just distribute the X, right? What's X times X?
X power 2,
And then X times 5.
5x,
And then you distribute the -4. -4 times X,
4x,
-4X. And then -4 times 5,
20,
minus 20. We did first, and then we did outer, and then we did inner, and then we did last. I didn't need this shit. Did I need this shit? No. Now, real quick, one of the big reasons why I hate that is because in general, I hate when we have mnemonic devices and music or songs, because yeah, I hate music. No, that's not what I'm saying. In mathematics, we make songs, we make little mnemonic devices, and it seems all cool. But then you get further removed from the idea. The idea here is easier than this makes it seem. Oh, you need this help. It's so hard. No, it isn't. It's repeated distribution, right? So I don't need that. If you like that, fine, use it. You don't need it. So then what can I do here?
Combine like terms.
x,
Okay. Now, let me show you one little cool thing with this. Get out of there. What could X be? What could X be?
2.
I love it. X could be 2, right? And so watch this. X could be anything, right? X could be anything. What if X is 2? What if X is 2? Why did I pick 2? Because Nikisha told me. That's all. What would this number be if X is 2?
-2.
Yes, 2 minus 4 is -2. What would this number be if X is 2?
7.
7. And now what would this be if X is 2? This would be 2 squared 4 plus X is 2 minus 20. This is 6 minus 20. This is -14. And what's -2 times 7? -14. So all we did when we multiply this number, this is a number right here. If I knew what X was, it would be a number. Times another number equals a number. Ooh, ground shaking. But the reason this is harder than multiplying numbers is because I'm multiplying an infinite number of numbers together. That's what we're doing, because what could X be? Anything. So when I multiply this times this and I get that, I'm multiplying an infinite number of numbers together. That's pretty good for a morning's work, right? What'd you do this morning? Slept in, what'd you do? I multiplied an infinite number of things together. Thank you very much. Damn. Let's see. So you guys try this one. Go ahead and multiply that out for me, please. Oh, Cameron, I have a very similar rant about that shit. The only use for that is for dumbass shirts about Camp Sokotoa and stuff like that. That actually makes it more difficult to do kind of semi-advanced trigonometry if you learn Sokotoa. It actually does. Yes, I have some really weird rants about math stuff. I know I do, and I don't care. So if you just learn that sine likes y and cosine likes x, you're golden forever. It works for every damn thing. What am I talking about? Everybody else, don't worry about that shit. That's some trigonometry stuff. What do you guys get? Anybody have the answer?
Yes.
What do you got?
8 m power 2 minus 12m.
Minus 12m. Interesting. Well, let's see. We have to work on that. So let's do this here. Let's see. 4m times 2m is 8m squared. I agree. And then 4m times 3 is plus 12m.
Plus 12m. Sorry. Plus, yes. Plus
And then
12m minus 10m plus 15. Oh, minus 15.
And then, of course, you could put these together.
2m squared.
No, careful. Be really, really, really careful. Now, listen. Let me make a big deal out of this. And Nikisha, this is not about you. This is about everybody making this mistake. What do exponents mean? What would m squared mean? What does it mean? Fundamentally, what does the squared tell you?
M times M.
Yes, it's based on multiplication. So exponents can only change if I am multiplying or dividing.
Oh, okay.
Yeah, so be really careful. I have so many m's and somebody took some of my m's. I can't suddenly have some m squares, right? So, and again, Nikisha, don't take this like I'm talking to you. I'm talking to everybody because that's a very easy mistake that everybody makes at some point. So when you're adding like terms, the variable piece stays exactly the same. It's only when I multiply variables that the powers can change. I like it. Good. And again, if you wanted to, you could do like we did earlier, pick a number for m, see what that is, and it would equal what that is after you put m inside, just like we did a minute ago. You don't have to. It's just a little side note, just a little interesting thing. And again, first, so FOIL, this stupid thing, it says it's supposed to be a way to remember what to do, which is really dumb, but okay, Jeff, stop. But you can see how it works. First, multiply the outer stuff, that's where we got that. Multiply the inner stuff, that's where we got that. Multiply the last stuff, that's where we got that. That actually makes it harder. That's dumb. That's just dumb. Just distribute this, bam, bam, and then distribute this, bam, bam. All right, I think I'll stop beating up on FOIL, but it just drives me crazy. So what about this? This is where FOIL really lets you down, right? If you love FOIL, it's about to let you down, hard. What if I do something like this to you? Now you got first, last, and middle. So what would it be? It would be I don't know what the hell. Can't be just FOIL anymore. But we know better. We don't need none of that shit. I don't care how many terms I put there. Don't I just distribute the x, bam, 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 and then distribute the -2, bam, bam, bam. So do it. Do it. Some of you guys are just looking at me. Do that. Somebody's here. Oh, somebody. All right, let me try to catch up to you guys. So what's x times x squared?
X cubed.
X cubed.
It's cubed, I like it. And then x times 5x,
5x squared.
and then x -1.
Negative x.
And here's something I like to do. -2 times x squared is -2x squared. I'll line it up. See, you don't have to do this, but I can line up my like terms. -2 times 5x, -10x. So I line up my like terms. -2 times -1 is +2. Poor little dude. It's got nobody to go with. So then I get x cubed plus 3x squared minus 11x plus 2. And again, if I let x equal a number, I could see what that number is, what that number is, and what that number is, and it would work. So here's the same kind of problem, but something very strange happens with this problem. Here we go. So you guys try this problem out. All right, do that problem. It's the same exact kind of problem, but something very strange is going to happen. Not, not like crazy strange. I did it and the answer was pineapple. No, it's not going to be like that. Oh yeah, this is where this happens. Okay, all right. Are you guys seeing what's happening? Anybody? So y times y squared, y cubed, y times -3y, -3y squared, y times 9 is +9y, and then you got the 3 gets a turn, 3 times y squared is +3y squared, 3 times -3y is -9y, 3 times 9 is 27. So then you get y cubed, die, plus 27. That's nifty. A lot of stuff died. All right, it's not that amazing. I'm sorry. I might have hyped that up a little too much, but it is interesting. Do you guys notice real quick. Do you guys notice that what is here, I put the square of it here. What is here, I put the square of it here. Do you guys see that? Do you guys also notice that this middle term is the opposite sign, 3 times y?
Yeah, that's the first thing I noticed.
Oh, okay. Thanks, Vu. I love it. So if I wanted to make one up, if I just put down here m minus 4, okay, so what am I going to put in the big dude? I'm going to put that squared here. I'm going to put that squared at the end. And in the middle, opposite sign for m. And then if I multiply this shit out, the same kind of thing is going to happen. I get m cubed plus 4m squared. Oops. Plus 16m minus 4m squared minus 16m minus 64. See how these go away? Isn't that mildly interesting? Like just barely interesting? Yes, isn't it?
Yeah, it's going to go tell someone about it.
Thanks so much, Vu. Vu is blatantly pretending to humor me. I love it.
Well, you could put it in 3 sets of parentheses rather than 2 as well.
No, you can't. How would you do it?
I was thinking of something else.
Exactly. I like it. But what's weird about the big dude, if that was twice what it is, if that was 8, then I could do what you're saying. So when you have a situation like this that works like this, that's always going to be half of what it would need to be. That's a very interesting side note. Way too much for what we need to worry about, but it is kind of interesting. Okay, so let's do this. That's the algebraic basics. And then the kind of problems we look at beyond just purely algebraic is stuff like this. All right, let's go through this together and then we'll call it a day. Shark Tank, why not? So read through this real quick for me. I am sharing, yes, thank God. Bam. So we're going to start to bring things together from earlier sections. So this should sound very familiar. We've done this before. Good old equation of a line. We did just use P here because we're talking about the price. Amazing. Instead of Y. So how would you find the M that you need for the equation? Oh, they kind of tell you, don't they? They tell me too much here. Find us a blah, 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 blah. So what are the 2 points I can write from what they tell me? Can you guys see the 2 points? She can sell 400 jars when she prices them at $12. So what's the point that I could write for that?
412.
Yeah, so it would be 400, comma 12. Selling 400 jars happens when it's a price of $12. So what's the other point I can write?
480.
Whoa.
10, 480.
480
480, 10.
and 10. I like it. Which kind of makes it think about what that means. Just think about what that means in the real world. If the price of something decreases, wouldn't that very often lead to more of them being sold? That's one reason why people lower the price, is to clear their inventory. Can you take a minute, figure out what this slope is? It's not going to be pretty, but oh well, too bad for us. Right. Or you could have done it the other way, but either way you do it, you end up with -2 over 80, -1 over 40. Can you finish that out for me? Can you guys? There's two ways you can keep going. Can you put it in this form? So you have to somehow figure out what B is. This is a good review. Can you finish that out? And just to remind you guys, if you want to, you can use this equation. I'm going to put P's instead of Y's. You can do it, Jeff. There you go, buddy. Right? You can do that, or you can do the other way that we did before where we figured out what B was more directly. It's up to you. Don't give up just because of the ugly fraction. It doesn't matter which point you pick. I picked the point 400, 12. You could use the other point. You end up with the same equation. Does this feel familiar? Remember doing this stuff? Wasn't that long ago? What's really nice about the ugly fraction is that it works well with 400, doesn't it? Negative times negative is positive. 40 goes into 400 10 times. That's awesome. Is everybody semi with me out there? You guys doing all right? All right, this isn't that long ago we did this. So then you add 12 to both sides and you get the price function. Okay. So let's remember that. I need to remember that. -1/40th, 22. All right, I'm going to clear all these away. Is everybody ready for that? All right, here we go. Bam. So we already did, well, oh, okay. So let me write up here. Let me see. Oh, okay. So the equation we just got for the price was this one. Oh, Jeebus, Jeff. Get in there. -1/40th x plus 22. So let's kind of keep track of that. So this is the price that she could set these jars at, right? And obviously the lower the price, the more she sells, but why doesn't she just want to make the price really, really low? Because then, I mean, she'll sell more. Let's just talk about this, not even mathematically, just real world shit here, right?
You won't make no money.
Exactly. If you take that to the extreme, if she just sets the price to 0, they're going to fly off the shelves, right? So there's got to be a sweet spot. There has to be a place where she could set the price and end up making her profit highest, or at least the revenue highest. So the next thing we'll talk about is the revenue. Now, what doesn't this make sense? How much do you figure if she sets her price at a certain amount, So let's say she sets the price at $15, and then she sells 10 items. How much money did she make? She sets the price at $15 per jar, and she sells 10 jars.
150.
150. So of course the revenue formula there makes sense. It's exactly what the hell you would do. You would take the price per item times the number of items. Of course you would, right? If I'm selling pet rocks and I make them $5 a rock and I sell 20 rocks, I made $100. We know that. So this formula doesn't make any of us surprised at all, right? But what's kind of new here is we don't know how many things we're going to sell. We're going to say that's X. And then what can I put in place of P? What do I know? What do I know this is? What do I know P is?
-1/40 plus 22.
Like, so see, this is trying to figure out the sweet spot. This is the work you do. So I don't know how many jars to sell, but I do know that if I did know this, I would multiply it by the price per jar to figure out how much money I'm bringing in. Now, of course, it makes sense. The next thing we'd do is to look like overhead and other costs, right? So what do we get here? Let me go ahead and multiply this in. This will be -1/40 x squared plus 22x. So that is my revenue function, and it is a down parabola, which makes sense. If I graph this bad boy out, it would be a down parabola. There is a sweet spot for the revenue. That will not be a sweet spot for my business because I haven't considered the cost yet. And again, I'm not suddenly making this into a business class. I hate business. I hate business management. I hate everything about business. If you love business, you're going to like this, I guess, maybe. Anyway, so don't worry. We're not going to get deep into business stuff. So here, let's put that on hold for a minute. There's my revenue function. We've got the revenue function all figured out. Try to do number 3 down here. This is another one just like the first problem we did, but now we're trying to figure out the cost. This one's a little bit easier than the first problem because they just kind of directly tell me what I need. Do you guys see that? Do they tell me what the slope is? Remember, another name for slope is rate. Do they tell me what the rate of cost is? Anybody? What do I have to pay even if I don't make any bath beads?
325.
Yes. So that's the fixed cost. That's the cost that does not depend on X. That's just, I got to pay freaking 325 no matter what. Now, how much more do I have to pay per jar?
$3.50.
So that's my slope. 350 times the number of jars would tell me on top of the 325 just to get my business going, I have to pay this much per jar. So that's why it's times X, because it depends on how many jars I sell, or in this case, make. All right, let me stop for a minute. Now, the next thing this is going to do is figure out the profit. Now, again, we're not getting too deep into business. This is not crazy economic theory. This is pretty basic business stuff. How do I get the profit from the revenue and the cost? What would be the money that goes in my pocket? So if you got the money coming in and the money going out, what do you do with those things to get how much profit you make?
And subtract.
Yeah, the money coming in minus the money going out. And of course, when this is bigger than this, that's when things suck. When this is equal to this, what do we call that point?
Break even.
Kick ass. All right, see how it all comes back together? So what is this going to be? It's going to be, well, we know what R is. It's this funky ass thing here. That's R. We figured that out earlier, right there. Bam, 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 bam. Minus the costs, which is this funky thing. Let me see if you guys are cool with this. So minus 350x minus 325. All right, this is a lot. This is a little more direct algebra than we've done in a while. So, but this is not that horrible, I hope. So it's writing equations of lines. It's multiplying some stuff together. It's writing another equation of a line. Yeah, it's not too terrible. All right, somebody keep this written down somewhere. Make sure you got this. We can do a little, what can we do to simplify this? I'm going to do that in a minute when I got some more room. But what's the one thing we could do to simplify this profit function? What's one thing I could do? Simple.
22x minus 3.5x.
Yes. So we got some like terms there. So I'm gonna clear this. We're gonna move down a bit. All right. Somebody got that written down for me? I'm gonna ask you for it here in a minute because I don't trust my memory. All right, here we go. I'm gonna clear it away. Back. So here they are finally catching up to us. Profit is revenue minus cost. Let me see. Let me make sure I don't miss anything. Yeah, so we got, that's the step we just did. Number 4, we already did. That's the profit. Blah, 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 bunch of crap. So do you guys, I want you to realize the one part to try to talk about here. Actually, let me see what they're going to do here next. So maybe I can do some more blah, 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 blah. Okay. We'll get there in a minute. So the one part that people really make a mistake on is when we did revenue minus cost, I've got to make sure that I subtract the entire cost. So remember the cost was, I don't remember anymore. It's right there, Jeff. Yeah, it's right there, buddy. You could do it.
325
X
plus
plus
350 per unit. Yeah.
Yeah, thank you. Right? So when I subtract the cost, so here's the revenue. Why do I keep doing that? I really wish I knew. Negative 1/40th x squared. What was it?
Plus 22x minus 350x.
Yeah. Minus 325, because I got to subtract the whole cost. I got to subtract this and subtract that. So another way to write that would be like this: minus the cost, minus the cost. But then you would just distribute the negative and make both of these negative. So that's the point they're trying to make. I think, where is it? Down here, number 5, of course, Jeff. Good job. So then if we do this all, we get negative 1/40th x squared plus, what would that be, Jeff? Would that be 1850? I think when you do 22x minus 350x. And then minus 325. Woo! There's our profit function. Now you guys are like, oh, this is too exciting, Jeff. But again, if this is your business, this is exciting. This is exciting in a bad way sometimes. Maybe right now, it's exciting in a bad way. Then I could answer all kinds of questions. So the kind of question they're going to ask you down here would be, okay, what if you sold 100 jars? What would your profit be? So what if they ask you, what if you sold 100 jars? How would you figure out what your profit would be?
Plug it into X.
Yes, good. Remember, X is jars. So all you would do is you take the profit function and you would plug 100 in for X. Ah, Jeff, you have no room here, buddy. So if I plugged all that in my old calculator, looks really, really gross, but oh well. Let's try it out. Let's see what we get. We sell 100 jars of bath beads. What has happened in my life that I am in charge of a bath bead store? But oh well. It's not my dream, but it could be somebody else's dream. That's fine. See if you guys can put all that in the calculator correctly down here. Let me see. Let me know if you get the answer.
I got the answer.
What do you got?
1275.
Gas. So if I sell 100 jars, I will actually pocket $1,275 because this has my cost in it. So obviously, the next thing you would be curious about is, well, how many jars should I try to sell so my profit is maximum? That kind of makes sense, right? So then you could go to Desmos, put this thing in Desmos and just see where that vertex is. That's going to be the maximum. How do I know this is a down parabola again? How do I know it opens down like this?
Because x squared is negative.
Because the x squared piece is negative. I like it. Kick ass. All right, so let me clear this. Clear, go away. Here it goes. Pop. So down here, yeah, so down here, let's see, blah, blah, blah. They ask you 200 jars. They ask you 600 jars. Yeah, so here's the funny thing. If the parabola looks like this, this is less of a math question, more just, so this means that if they sell more and more jars, why is the profit going down now? Why is there a sweet spot? Why, if they sell more jars past the spot, why is their profit going down?
The cost of making it.
Yes, that's where the cost of making the jars starts to catch up to the revenue made from selling the jars. Woo! All right, so we're right on the edge of becoming a business administration class, but we're not going to fully go into there, thank God, because you don't want me teaching you business. That's for damn sure. But this much I can handle. I can handle this much. Okay. Let me clear this away. It's not very useful. Yeah, and this is the part. Now, here's what I was thinking about. It's not the last section. It's this section where they ask you in the homework to use a calculator or a computer, and that's where you can use the Desmos thing. If you have a TI calculator, you could use that too, and you could just take a picture of it, right, when you turn in your homework. So there is one question in the homework that asks you to use a calculator or the computer to graph something. Let me see. Is anything interesting here? No. Nothing interesting here. Old stuff. Blah, 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 blah. Old stuff, old stuff. It took them a while to catch. And then here's just a bunch of like terms, and then they get into multiplying stuff out. Okay, okay. All right. I think that's enough. I think that's enough. So we'll do some review of this tomorrow, and then we'll just keep on going because we're headed into some sections that are a little more difficult, believe it or not. So it's kind of nice. We're going to have some time to go through those. But I think for right now, I think that's enough for today.
Okay, you said we're going to do some of that tomorrow.
Not tomorrow. You know what I mean.
Monday.
Whenever I say tomorrow, I mean in terms of
next time we come. Yeah, okay.
Next time we meet. Yes, thank you. It is Thursday, so let's not meet tomorrow. Let's meet Monday. And next week, of course, we only have class on Monday and Tuesday because I give you Wednesday off in addition to Thanksgiving. So next week is just Monday and Tuesday. So go ahead. You can get started on the quiz now if you want to. It should be open. You have until tomorrow morning to get it done. Okay.
Yeah. Okay, Jeff, I have a question.
Yes.
Wow, I was tripping off of that sweet spot you was talking about in regards to the business.
Yes.
And then you said that the cost of the paying for the jar, you know what I mean, for the product and the stuff like that starts to catch up.
Yes.
The more that you make, can you explain that a little more? I mean, what do you mean by that?
Help me out. Let's look at these individually, real quick. All right, so remind me. So here we go. I think I can get this stuff back down here. So we got let's look at each of these individually, real quick. So like the profit, I'm sorry. The revenue was -1/40 x squared plus, I can't remember now. Was it 22x? No. Do you remember what the revenue was?
Is plus 22x.
140 plus 22.
22x? All right.
Mhm.
The price, I'm talking about the revenue, yeah. And the cost was 350x
50
plus,
plus 325.
I like it. Now watch this. What's, how much revenue do I make for doing 200 jars? Let's just do that. So I plug a 200 in here, right? -1/40 times 200 squared. Stay with me now. This is a little bit of a long way to go to answer your question, but I want to show you the, so -1/40 times 200 squared plus 22 times 200, I get $3,400. And then down here, the cost of 200 would be 3.50 times 200 plus 325.
Yeah.
So I get
What's that? 30, what? 350, 700 plus 10,225. Yeah, I mean 1,000.
at 200 jars, the revenue outpaces the cost. But now watch this. Let's try 600 jars. That'll be -1/40, 600 squared plus 22 times 600.
It's going out, yeah.
Where'd it go? Oh yeah, 3.5, 600 plus 325. All right, so that's
375 to 1,075.
so I get a revenue. If I do 200 jars, my revenue is 4,200, but my cost
3,075.
is 2,425. Have I got that right?
You sure?
Yeah, it looks about right.
200 is 1,025. 400 to be 2,050, right?
No.
No,
No. Because this 325 is not affected by.
it's not moving. Yeah,
That's why it doesn't completely triple.
right.
Just a piece of it triples. Yeah. So be careful about that.
Okay.
All right. Do you see how here these are 2,000 apart, and here these are 1,800 apart roughly?
And so, yeah.
So you're gonna reach a point. I was hoping it would be 600, but obviously not. You're gonna reach a point like maybe 2,000 jars or something, where the cost will overtake the revenue.
Right.
There will be a point where the cost catches up and overtakes the revenue.
Right.
So that's why you
I
don't
see.
want to sell too much. Now, obviously, I really want you guys to understand, this is basically what happens, but the actual formulas in real life will be a little more disgusting because they involve more variables. but this is the real basic idea behind what's going on.
Well, I'm looking at it because I got a business and I know I was looking at the math of it, but a lot of times when I go out and I get my contracts and stuff like that, I do run into a situation like this every now and then.
And this is all about, this is like if you have to set your price point.
Right.
I don't know if you sell services or if you sell goods, because it could be very different for services.
Yeah.
Ah, okay. Services
And
might
then
not
workers and then all that. You gotta put all that in.
There's a
Material.
lot more, you know all too well, there's a lot more variables than what's happening with this problem, right?
Right.
Okay, but the math fundamentally is the same. You would just have equations with a few more variables. I'm sure you have software that maybe you plug in some variables and it figures out some stuff for you, or you use Excel spreadsheets or something. I don't know.
Yeah, I usually use my brain but this would be better for me. You know what I
Okay.
mean? I just look at where I'm gonna make some money at,
Yeah.
opposed to and then I just keep
So, I
over my
mean,
taxes. But I'm learning the math of it now. Looking at the math of it is a little different, and that
Yeah.
kind of twisted me when I said the more money, the more I make, and then it's gonna hit a point to where the more I sell, it's gonna start catching up with it. You know what I mean?
I
That blew
want
my
you to
mind.
remember, in order to sell more items, the cost of the items had to be decreased, remember?
Right.
Okay, and that was the very first thing that was discussed. Not every business will necessarily follow that exactly.
Right.
Does that make
right.
sense? And not
Right,
every
that makes
business
a lot
will
of
have
sense.
linear. Not every business will have a linear relationship between.
Yeah, I don't have no. Yeah.
Yeah. So the math gets more disgusting, but it fundamentally is still the same idea.
Same idea.
Yeah. So
That's
I'm
the
not
same
saying
thing.
you can't
Go ahead.
take what we're doing now and directly apply it to a business and be okay. You're going to
Right.
need a little more math on top of this to really be
Right.
able to apply it directly. Yeah.
Okay. All right.
Okay.
That was like, I mean, as soon as
it's
you
kind
said
of,
that, I was like, that was all I was thinking about the rest of the class.
this thought process is the same thought process. The math will
Yeah.
be more disgusting for a real life business, but the thought process is the same. Yeah.
Okay.
All right.
All right,
How's
Jeff.
everybody
Thanks a
else?
lot. Appreciate you.
You're welcome.
Have a good weekend.
You too. Everybody else okay out there? I'm going to head out. All right. I'm out of here, guys.
Bye.
Bye-bye.